95 tons of rock, 150 million years of silence. And then a shape begins to emerge. Plates like sails, a tail built to kill. This is Stegosaurus, one of the most recognizable dinosaurs on Earth and one of the most misunderstood. Today, we're going to meet the real fossils behind the legend, walk the ground where they were found, and learn exactly how scientists proved these bones are 150 million years old. Stegosaurus lived during the late Jurassic period, roughly 155 to 145 million years ago. It was a plant-eating dinosaur, walking on 4 thick legs with a small, low-slung head built for stripping leaves rather than fighting. Adults could reach up to 9 meters, about 30 feet in length, and weigh several tons. But its real signature is on its back, a double row of large, upright, bony plates running from the neck to the tail, followed by 2 pairs of sharp spikes at the tip of the tail, a structure paleontologists nicknamed the Thagomizer, after a joke in a Far Side comic strip that remarkably stuck as real scientific slang. The plates were not armor in the traditional sense. They were embedded in the skin rather than fused to the skeleton, and current research suggests they were likely used for species recognition, display, and possibly temperature regulation, given the rich network of blood vessels found inside them. The story of Stegosaurus begins in 1877, in the middle of one of the most bitter rivalries in the history of science, the so-called Bone Wars between paleontologists Othniel Charles Marsh and Edward Drinker Cope. A quarry worker near Morrison, Colorado, uncovered strange curved bone plates unlike anything seen before. When the fossils reached Marsh at Yale, he initially thought the plates lay flat across the animal's back like a turtle's shell, hence the name Stegosaurus, meaning roofed lizard. It would take decades and many more skeletons before scientists corrected the posture. The plates stood upright, staggered in 2 alternating rows, not lying flat like tiles. Early reconstructions were riddled with guesswork. Marsh even initially assumed the small pelvic bulge near the hip housed a second brain, a myth that persisted in textbooks for 100 years before being properly debunked. The structure was almost certainly a nerve bundle supporting the hind limbs and tail, not an actual brain. Let's meet some of the actual skeletons that shaped what we know. First, the hollow-type slab. Many of the earliest, most scientifically important Stegosaurus stenops remains were recovered still partially embedded in their original stone matrix, a jumble of vertebrae, ribs, plates, and limb bones, locked exactly where they fell 150 million years ago. These slab mounts are treasured because they preserve the taphonomy, the story of how the animal died and was buried, not just the bones themselves. By the mid-20th century, museums had refined mounting techniques, assembling composite skeletons, often blending casts from multiple individuals, into freestanding displays that let visitors walk around a living pose. And then, in 2024, a specimen arrived that changed everything we thought we knew about how complete a Stegosaurus skeleton could be. Nicknamed Apex, it was recovered from private land in Colorado's Morrison Formation. At roughly 11 feet tall and nearly 27 feet long, Apex is considered the largest and one of the most complete Stegosaurus skeletons ever unearthed, with about 254 fossilized bone elements recovered, an extraordinary completeness rate for any dinosaur this age. Apex later became famous for another reason. It sold at a Sotheby's auction in 2024 for over $44 million, making it the most expensive dinosaur fossil ever sold, surpassing even the record set by the T-Rex specimen Stan.
Getting a skeleton this size onto public display is its own feat of engineering. Today, Apex stands on permanent exhibit, a reminder that even after nearly 150 years of study, the Morrison Formation still has secrets to give up.
Almost every significant Stegosaurus discovery, including Apex, traces back to one extraordinary rock unit, the Morrison Formation. The Morrison Formation is a vast sequence of late Jurassic sedimentary rock stretching across Colorado, Wyoming, Utah, Montana, and several neighboring states. It formed roughly 155 to 145 million years ago, when this region was a broad floodplain crossed by rivers, seasonal lakes, and stretches of semi-arid plain, not unlike parts of the African savanna today, but populated by giants. Stegosaurus, Allosaurus, Diplodocus, Brachiosaurus, and Camarasaurus all lived and died in this same landscape. What makes the Morrison Formation so important isn't just the number of dinosaurs it preserved, it's the quality of preservation. Seasonal flooding buried carcasses quickly in fine river sediment, and mineral-rich groundwater then infiltrated the bones over millions of years, gradually replacing organic material with stone in a process called permineralization. That's what turns bone into fossil. Modern excavation of a Morrison Formation site is a slow, careful science. Teams first survey exposed rock for weathered-out bone fragments on the surface, which hint at what's buried beneath. Once a productive layer is found, workers remove overlying rock, called the overburden, with hand tools, then carefully excavate around each bone, leaving it sitting on a raised pedestal of rock. Bones are then wrapped in plaster and burlap field jackets, exactly like a cast for a broken arm, to protect them for the journey to the lab, where preparators spend months, sometimes years, carefully removing the surrounding rock under microscopes. It's one thing to find a dinosaur skeleton. It's another to prove with confidence that it is 150 million years old rather than 15,000. That certainty comes from two complementary sciences, stratigraphy and radiometric dating. Stratigraphy is the study of rock layers, or strata. The basic principle, called the law of superposition, is simple. In an undisturbed sequence of sedimentary rock, older layers sit at the bottom and younger layers sit on top, like pages stacked in a book over time. By identifying which layer a fossil comes from and comparing that layer to others around the world containing similar, well-studied fossils, a technique called biostratigraphy, scientists can place a specimen into a relative timeline before a single number is attached. But stratigraphy alone only gives relative age, older than something else. To get an actual number in years, scientists turn to radiometric dating. Radiometric dating relies on radioactive decay, the fact that certain unstable isotopes break down into stable daughter isotopes at a fixed, measurable, and utterly reliable rate called a half-life. For rocks the age of the Morrison Formation, scientists typically don't date the dinosaur bones directly. Instead, they date volcanic ash layers found within or near the same rock sequence, because volcanic minerals, like zircon crystals, contain trace amounts of uranium that decay into lead at a known rate. By measuring the ratio of remaining uranium to accumulated lead within a single zircon crystal, geochronologists can calculate with a very small margin of error exactly how long ago that ash layer settled. If a dinosaur skeleton was buried in sediment sandwiched between two dated ash layers, its age can be bracketed with remarkable precision. This combination, relative dating through rock layers and absolute dating through radioactive decay,
is why paleontologists can say, with real scientific confidence, not just "this is very old," but "this animal died in a specific, narrow window of time, roughly 150 million years ago."
Fossils tell us the shape of an animal. But what did Stegosaurus actually look like moving through a Jurassic forest, alive? Modern paleoartists work closely with anatomists to build reconstructions grounded in the actual bone evidence, muscle attachment points, plate vascularization, skin impressions found alongside a handful of specimens. The result is a far more dynamic, textured animal than the stiff museum reconstructions of the early 20th century. A heavy-bodied, deliberate herbivore, plates likely flushed with color for display, moving through fern-covered floodplains alongside towering conifers. From a jumble of confusing bones misread as a turtle-shelled reptile in 1877 to Apex, a $44 million near-complete giant unveiled to the world in 2024, the story of Stegosaurus is really the story of science correcting itself. Every plate, every spike, every layer of rock, and every decayed atom of uranium has added one more piece to a picture that took over a century to come into focus. And the Morrison Formation is still out there, still eroding, still surrendering new bones every field season. The next apex might already be sitting in the ground, waiting. If this journey through 150 million years of Jurassic history got you hooked, hit subscribe so you don't miss the next deep dive, and drop a comment below. If you could stand next to any dinosaur skeleton in the world, which one would you choose and why? I'll be reading through the answers, so let's talk dinosaurs down there.